Hi, welcome back. Today we're going to look at section 2.3 in our Calculus 1120 class, which is more about limits. So we're going to continue with our knowledge and work with limits, and hopefully by the end of this section you'll have a few more good techniques under your belt. So at the top it says, we found limits of functions in a previous lesson by looking at the table of values, looking at graphs, or through algebraic techniques. We will now use a more formal approach to evaluating limits by introducing a list of properties of limits. So we've already done a lot of things, but today we're going to learn a few more and just kind of go through some more definitions. Okay. Um, Biggest one, I think, well, two big ones today is we're going to learn a few different algebraic techniques. We've basically just been factoring. So we're going to do something different today with that. And then we're also going to look at limits when x goes to infinity, which we haven't done a whole lot of yet. Okay. All right, so today, the overview, what we're going to do, find limits of rational functions, which we've been working on pretty much, and then we're going to use the properties of limits to determine limits of functions. Okay, so new concepts, new definitions. Number one says that suppose that C is any constant, N is a positive integer, A is a real number, there's a lot of stuff in there, so C is a constant, N is a positive integer, A is a real number. The limit as x approaches A of f of x equals L1, and the limit as x approaches A of g of x, different function, equals L2, and L1 and L2 are real numbers. Okay, so a lot of stuff going on here. But basically, if you take the limit of one function and you get a number, and you take the limit of another function and you get a different, you get the same number, but they're two totally different answers, okay? But at least we know that L1 and L2 are real numbers. Then all of these following properties are true, okay? So you don't really need to memorize or go too crazy about what you're seeing here. It's just kind of making sense limits. So remember, if two limits of two different functions exist, then these things are true, okay? So first off, the limit of a constant, okay? C is a constant. So if you're asked to find the limit as x approaches A of some constant, then your answer is the constant because there's nowhere to plug in that number. A constant is just a number. So the limit of just a number as x goes to anything would just be the number. Okay, the limit as x approaches A of x is always A. Because remember, you're plugging in this number for x, so of course you're going to get A. The limit as x approaches A of x to the nth is going to give you A to the nth. Again, you're just plugging in A into your problem for x. We've been going through this, right? That's the first rule of thumb, is plug the value into your function. All right, so those three kind of make sense. And these three start looking confusing, or these four, sorry, start looking confusing, but they really aren't if you kind of just think about it. So the fourth limit property here says that the limit as x approaches A of f of x plus or minus g of x. So if you're adding two functions together or subtracting them, that's the same as if you take the limit as x approaches A of f of x first, and then take the limit of g of x as x approaches A second, and add them together, you will still get the same limit, okay? The limit of L1 plus L2. So you can add the functions together first and then take the limit, or you can break the two addition subtraction problems apart, take the limits separately, and then add the limits together, okay? So either way would work. That's what that says. Same thing with multiplication. If you have two functions being multiplied, you can multiply them together first, then take the limit. Or what's on this side says take the individual limits first and then multiply those together. Okay, so it's just kind of algebraically and mathematically telling you that limits can just stay with each function separately, or you can combine them first. It doesn't matter. Okay, same for division. As long as you're not going to get 0 in the bottom, okay, as long as the bottom is not 0. You can divide the limits and then get your answer, or you can get each individual limit first and then divide the limit answers. So whichever way kind of seems easier, better, whatever works better in the problem. And then the last one on this first page says the limit as x approaches a of a constant times a function. Well, again, I can just take the limit of the function part, which should be easier, and then just multiply that answer times the constant. Okay? So most of these rules we kind of already know. They're just kind of straightforward, but they're just now saying that they work with limits as well. Now, we've got another couple bullets to kind of go with these. So on the next page, these go with the ones that are up here. So we've got 2 more. And this is the square root. So if you have the limit as x approaches, sorry, not a square root, any root, nth root. So if you have the limit as x approaches a of a function taken to any root, okay? It's the same thing as if you take the limit of the function first, take the limit underneath first, and then take the root of just that answer. Okay, so again, the limit can be interchanged. It can stick with the function. You don't have to do the hard part first. You could take the limit first, then do the simplifying. And then the last bullet on this one, number 1, says if p is a polynomial function, then the limit as x approaches a of p of x is p of a. That's what we worked on last time. If you have a polynomial, you just plug in the value and work it out. That's what that says. We're going to plug in a for x. Okay? All right. Now, number 2 is about rational functions. So we've done work with rational functions. We know we can factor. We know we've got some different things. We know that we should always plug in the number first and see what we get, what kind of form we get. So we've learned a little bit about rational functions. So this is just a little bit more information. So number 2 says a rational function is a function of the form f of x equals p of x over q of x, where p of x and q of x are polynomials. So, right, rational functions, a polynomial over a polynomial. Okay, so just kind of keeping that in mind. We've already been working with those. We've done them in a couple last couple sections. All right, so these polynomial, okay, or rational functions, now we're going to be looking at what happens when x goes to infinity. So we've been looking at x goes to a number. So now we're looking at x going to infinity. So it says the limit as x goes to positive infinity of 1 over x equals 0. I will tell you that this is true no matter what the power is here. Okay, so if you have a constant over x, or x squared, or x cubed, or 5x, okay, it could be anything with x. As long as there's a constant in the top divided by a variable in the bottom, and you are going to positive or negative infinity, 3 and 4, you will always get 0. So you don't have to do a lot of work for those. Okay. Number 5 is another indeterminate form. Remember we did the 0 over 0? So if you're going to infinity and you plug infinity in the top and the bottom and you get infinity over infinity, that's another indeterminate form, which means you're going to possibly get an answer. And so it says to determine what the limit is, we're going to divide each term by the highest power of x. We're going to do that in a minute, but the reason why we're doing this is because it's going to end up bringing us back to here. And this is easy, so that's what we want to try to do, okay? All right, and then number 6 says for f of x equals, so this is a polynomial over a polynomial, okay? Where a sub n is not equal to 0 and b sub m is not equal to 0. So basically the coefficients of this highest power term have to be numbers. Can't have 0 there. Then one of these 3 things is going to be true. Now remember, m and n are the exponents, right? The highest exponent in your polynomial. So if your exponent in the bottom, m is the bottom exponent, equals the exponent in the top, then the limit, if you're going to infinity, of that function is the coefficient divided by the coefficient. Okay, a sub n divided by b. So this looks very complicated, but it's really not. And I'm going to write here the words equal degrees. You're going to hear me say that when we go through these. So if the top and the bottom have equal degrees, then your limit is going to be the coefficient, leading coefficient, divided by the leading coefficient of the denominator, okay? So we'll look at that. So it's not as bad as it looks. All right. For m is greater than n. So m is, remember, the denominator, the exponent in the denominator. So if the exponent in the denominator is bigger, I'm going to call that bottom heavy. So if the exponent in the bottom is bigger, I call those bottom heavy polynomials, so the degree is bigger in the bottom, then your limit as x goes to infinity is 0. So those are nice. That kind of works with numbers 3 and 4 up there. And the bottom has the bigger degree. And the last one says what happens when m is less than n. Well, that means the degree on the top is the bigger number, so I call that top heavy. And if it's top heavy, then the limit is either going to go to positive or negative infinity. We got to figure that out. And we're going to figure this out by multiplying. This says divide, but we're going to divide each term by the highest power of x. I usually multiply by 1 over that, but we'll go with that. We're going to divide by the highest power of x. Okay? All right. So a lot of little things going on here, but really not too terribly bad. You just got to practice and make sure you understand and are working with the limits. But remember the rules. You always want to start by plugging in the number first, no matter what you have. Plug it in. And then the infinity ones, we're going to use those 3 rules we just went through. All right, so this page, we're looking at x going to a value. Okay, we're doing limits as x goes to a number. And then at the end of this unit, we're going to do the x goes to infinity problem. So they're different. Okay, so if you look at all this page, x is going to a number. Okay, so that has to do with the definitions that were on that first part. Okay, so number 1, find the limit as x approaches 61 of 97. So this is a constant. So I don't care what this is, this function is always 97. No matter what x is, 97 is the answer. So that's that first one that said the limit is just that constant. Okay, so 97, not 61, because remember, you're supposed to plug 61 in for x. Well, if there's no x, then I'm not putting 61 in here. My answer is always going to be 97. All right, number 2, the limit as x goes to 1/2 of 7x plus 1 over 10x plus 18. Again, plug it in. So if I plug in 1/2, 7 times 1/2 plus 1 over 10 times 1/2 plus 18, I'm going to get an answer here. So that's going to be my limit. So 7 times 1/2 is 7 halves, which is 3.5. Do it that way, right? 7 halves is 3.5. 10 halves is 5 plus 18. So that gives me 4.5 divided by 23. Okay. So 4.5 divided by 23. Do that on my calculator. It's dark over there. So 4.5 divided by 23. All right, so we get that decimal. Hawks most likely is going to want you to write a fraction answer. So again, I can change this to a fraction. So this is good practice if you forgot how to do that. So to go to a fraction, math button, which is right here. Okay. Number 1 says fraction, so hit number 1 and then enter. So 9 over 46. Now you could have done this, you could have left this 7 halves plus 1, okay? You could have worked it out as fractions, but I know typically a lot of you guys don't like fractions, so it's fine to use your calculator. It's fine to need help on that, but you don't need to get it wrong because you don't know how to work with fractions, okay? So just make sure you know how to use your calculator. All right, so 9 over 46. That is the limit. All right, number 3. The limit as x goes to 2 of x squared minus x minus 2 over x squared minus 4. If I plug 2 into here, I'm going to do this on the side because I believe I'm getting 0 over 0. You don't have to, but I just want to have work area for you guys. So first plug in 2, you get 2 squared minus 2 over 2 squared minus 4. So we're always going to check and plug this in. This is going to give me 4 minus 2, which is 2 minus 2, which is 0. And in the bottom, 2 squared is 4. 4 minus 4 is 0. So I thought we were going to get 0 over 0. So that means I can factor, or today we're going to learn some different things. But this one, I believe we can factor. So this is good practice from what we did last time. All right, so remember, when you're simplifying or factoring, you're going to keep the limit in your work. Do not get lazy and drop that off. Only time you can drop off the limit is when you're just plugging in numbers, okay? But if you're doing some simplifying or changing or factoring, you got to keep that. All right, so in the top, that's a trinomial, so it will factor into 2 binomials. So I know the first 2 terms, since I need x squared, would be x and x. I know in the back, the only way to get 2 is 2 times 1. And then I just need to figure out my signs. I need a negative 1 in the middle. So if I need a negative 1 in the middle, the 2 has to be negative, the 1 has to be positive. The bottom is the difference of squares. So the square root of both, and then one gets a plus sign, one gets a minus. So the square root of x squared is x. The square root of 4 is 2. So that's going to be x plus 2, x minus 2. Okay? Now we can simplify. Anything common to the top and the bottom can cancel. So we are left with the limit as x goes to 2 of x plus 1 over x plus 2. All right, so now I can plug 2 in again. Now I have a simplified polynomial. So now I'm going to plug in 2 again. And as you plug in 2, then you don't need to write the limit anymore. So we're going to do 2 plus 1 over 2 plus 2. So we get 3/4. So there's your limit. So that's one from last time. Okay, you always plug it in to see what form you get, and that'll help you decide what you need to do. So this one was a factoring problem. All right, number 4, the limit as x goes to 4 from the left. Always remember, you still plug it in at that value. Doesn't matter if it's left or right, you can still double check. So 4 squared minus 16 over 4 squared minus 9 times 4 plus 20. I still think we're going to get 0 over 0, so 4 squared is 16. 16 minus 16 is 0. And in the bottom, 4 squared is 16 minus 9 times 4 is 36 plus 20. Yeah, so we're going to get 0 over 16 minus 36 is negative 20 plus 20 is 0. So that's what I thought. So we can also factor number 4. Okay, so let's see what we get. So the limit as x approaches 4 from the left. The numerator is a difference of squares, so that factors x plus 4, x minus 4. All right, take the square root of both. Don't forget one gets plus, one gets minus. And then here, it's a trinomial. So I know to get x squared, I'm using x times x for the first terms. And then for 20, I need factors of 20 that add up to be 9. So remember, there's only so many ways to get 20. 1 times 20, 2 times 10, 4 times 5. Right? That's it. One of those combinations will add up to be 9, which is right here. So that's how I know which ones to use, 4 and 5. And then you got to figure out your signs. You need a negative 9. So to get a negative 9, you need a negative 4 and a negative 5. Okay? All right, so again, I see that I can cancel the x minus 4s. So now I'm left with the limit as x approaches 4 from the left of x plus 4 over x minus 5. And now you can substitute in 4 again, see if you get an answer. Okay? So if we plug in 4 this time, 4 plus 4 over 4 minus 4, we get 8 in the top, negative 1 in the bottom, so we get negative 8. Okay, so the limit is negative 8. Okay. All right, so far, still kind of working on what we did, but we're always checking. We're always starting by plugging in that number, right? All right, let's check out number 5. The limit as x goes to 0 from the right of x over negative 14x squared plus 13x. All right, so let's plug it in. So if we plug in 0 in the top, we get 0. You plug in 0 in the bottom, you're going to get negative 14 times 0 to the 5th plus 13 times 0. So all of that in the bottom is 0, right? 0 times 14 is 0. 13 times 0 is 0. So everything is 0. All right, so that means we can do some work. So the limit as x goes to 0 from the right. Can't do anything with x, but in the bottom, do you see anything you can do here? Hopefully you see that both of these terms at least have an x in them, so I can factor out an x. So if you take one x out of each of those terms, this will go down to x to the 4th, and that x will disappear, right? All right, so I took one x out of here, left me x to the 4th. I took this x out of there, left me the 13th. Now these will cancel. Remember, when everything cancels in the top, you're left with a 1, not nothing, right? So this is the limit as x goes to 0 from the right of 1 over negative 14x to the 4th plus 13. All right, so once you've got it simplified, now we're going to plug 0 in again. So this time when I plug in 0, I get 1 in the top. I get negative 14 times 0 to the 4th plus 13. That's going to give me an answer. So I have 1 in the top. Negative 14 times 0 to the 4th. 0 to the 4th is 0. 0 times negative 14 is 0. Plus 13. So you end up with 1 over 13. So there's your limit for that. Okay? All right. Now, 6 and 7, a little bit different. We haven't done radicals yet. And so with radicals, you can't really factor. So this is another algebraic technique for trying to figure out indeterminate form. Okay? All right, so first off, plug in 100. If you plug in 100, the square root of 100 minus 10 over 100 minus 100, the square root of 100 is 10. 10 minus 10 is 0. And 100 minus 100 is 0. So this is telling you you will get a number answer. Problem is now we can't factor. There's no way to factor with a radical. So we're going to use a technique called multiplying by a conjugate. Okay, conjugate. So a conjugate, if you remember in algebra, when you have a radical, a conjugate is the same two numbers with the opposite sign in the middle. So the conjugate of the square root of x minus 10 would be the square root of x plus 10. And when you have radicals, you always do the conjugate of the part with the radical. We don't care about the part that's not a radical. All right, so here's what you do when you have radicals. I'm going to write the problem down. Okay, I'm going to parentheses around both of these because I need to do some work. So write the problem down, split them up kind of like this, and then multiply the top and the bottom by the conjugate of the part that has the square root in it. Doesn't matter if the square root's in the top or in the bottom. Okay, so if you look at number 7, the square root is in the bottom, so that's the term we want the conjugate of. Okay, so always look for the conjugate with the radical. So the conjugate of the radical term would be the square root of x plus 10, opposite sign. So whatever you do to the top, you got to do to the bottom. So you don't want the conjugate of both. You just want the conjugate of the term with the radical. And then you're going to multiply the top and the bottom by that. All right. So that's how you set this problem up. Now we're going to FOIL. Okay. First, outer, inner, last. Looks kind of nasty, but because this is a conjugate, it actually is pretty nice. So when we FOIL, the square root of x times the square root of x, that's just x. The outer and the inner are going to cancel out all the time. So look at this. Square root of x times 10 is 10 square root of x. But negative 10 times the square root of x is negative 10 square root of x. So those guys are always going to cancel out. Okay, I'll write it over here. You got 10 square root of x and a minus 10 square root of x. So it's always 0. So when you multiply conjugates, you only have to do the first and the last. So we did the first, square root of x times the square root of x. That's the square root of x squared. That's where the x came from, okay? And then negative 10 times 10 is minus 100. That's all you have to do. And then in the bottom, the part that's not the conjugate, you just leave it the way it is. You don't even have to multiply the bottom, okay? You only multiply the piece that's the conjugate. All right, and hopefully now you can see why. I don't want to multiply the bottom out because I can cancel this, okay? So let me go through those steps again real quick. So when you have a radical in one of the two parts of the fraction, take that part and multiply the top and the bottom by the conjugate of the term with the radical. Multiply or FOIL out the conjugate part, leave the other part alone. And then now we're at the step where we're going to simplify, and we can cancel this with this. Okay, so again, when you cancel and everything goes out of the numerator, remember there's a 1 up there. So we have 1 over the square root of x plus 10. Now we're going to substitute in that 100 again. We're going to find the new limit. So now we can plug in 100. So 1 over the square root of 100 plus 10. That is 1 over, what is the square root of 100? That's 10 plus 10. So we end up with 1 over 20. Okay, so there is the limit for that. We're going to do the same thing with number 7, so we'll practice this again. Okay, the nice part about number 7 is the square root is in the bottom, so you'll see it doesn't matter. You still do those same things. Okay, all right, so again, we're going to start though by plugging in 25 because maybe I'll get an answer. But if I plug in 25 in the numerator, I get 0. And if I plug 25 in the bottom for x, square root of 25 is 5. 5 minus 5 is 0. So I still got to do what I did in number 6. All right, so limit as x goes to 25. Put each one in their own parentheses. Okay. All right, now which one do you take the conjugate of? Okay, you take the conjugate of the term that has the square root. So the conjugate of the square root of x minus 5 is the square root of x plus 5. And whatever you do to one, you got to do to the other. Okay. All right, so that's the first part. Now, the part that's the conjugate is the part you're going to FOIL or multiply out. The one that doesn't have a conjugate, you leave it alone. So this time, I'm going to leave the numerator alone. So don't mess with that. You only want to multiply the conjugate. So that in this problem is the denominator. And when you do the conjugate, remember, you just do first and last. So square root of x times the square root of x is the square root of x squared, which is x. Minus 5 times positive 5 is minus 25. You don't have to do the outer and the inner because they will always cancel out. You can, but you don't need to because they will always cancel out. All right, so now notice what happens. This cancels with that. So now you are left with the limit as x goes to 25. This is in the numerator. Your denominator is 1, so you don't need to put this over 1. You could, okay, but this is in the top. So now you're going to plug in again and evaluate. So now we're going to plug in 25 to this problem. Square root of 25 plus 5. So square root of 25 is 5 plus 5 gives you 10. So there's your limit. Okay, so that's a new method for simplifying algebraically. The first one we did was factoring. And so now you're looking at a radical. So when you have radicals, you use conjugates. So that's basically the two types you're going to have. Either the conjugate will be in the numerator or the conjugate will be in the denominator, but the same rules apply. Okay? All right, so again, follow these notes if you're working your own problems if you need some help with that. All right, so I'm going to stop here just to speed up my uploading on YouTube, and we'll pick up with number 8 on part 2. Okay, so I'll see you back here in a sec.